And we are live.
All right, thank you, John. Good evening, everybody. My name is Tim Hicks. I am the current chair of SAE Chicago section. And tonight, you're all here, obviously, to see a presentation on Guardhat, the connected worker technology and the hierarchy of controls. Our speaker will be Rakesh Panda, and I'll get a little more details on him and his background here in a minute. So I just wanted to give a quick overview of SAE for those that may not be familiar. We're a resource for people involved in all aspects of actually beyond vehicle mobility, getting more into aerospace, the push from SAE International. But we're one of the largest sections of SAE International. There's over 200 companies represented, and I'll show you some of that here in a minute. But some of the benefits of being a member of SAE, obviously for networking, company presentations like we're seeing tonight, volunteer opportunities and events, technical resources for papers and standards, and then for this type of thing, again, for professional development. For students, for those listening that may not be a student member of SAE, again, networking, very important, having the resources available from the section. Job opportunities, there was a recent email blast that went out with all the board members, companies that they represent, and the entry-level type opportunities at their companies. Mentoring opportunities, and then participating in our board meetings, as Anmol Sharma, who is at and coordinating the IIT portion of this tonight, participates in our monthly board meetings. So we have a little over 1,000 total members, just under 1,000 professional paid members, approximately 140 university students. And then you see the 5 universities that are represented, or at least that we participate in from that perspective. Just to give you a flavor of our current board and the types of companies, I'm not going to go through this whole list, but you can see on the right-hand side the companies that are from our board officers. You can see Navistar, Waymo, Parker, Hannafin, who is sponsoring the Zoom link tonight for everybody. Collins Aerospace, SKF, ESI is another consulting firm, and then a few retirees that are continuing to participate. So we have everything from student members of the board to retirees. So we got the full spectrum covered from our board standpoint. To follow and get them more involved in SAE, you can visit our website there at just chicagosae.org. You can follow us on LinkedIn or on Twitter. And then we don't have any current events scheduled, but you can get a flavor for the types of events that we're working on, trying to get organized. I mentioned our board meetings. We meet the second Tuesday of every month. We will not be meeting in December, but our next meeting would be in January then. You're welcome to participate in those to get an idea of what the board gets involved with. We're looking at ethanol as a fuel. Chicago Auto Show, we try to do something at least pre-pandemic, an event around the auto show, and we typically have that around the media day. So we get special access to the show for that. And then a couple others that are in the preliminary stages, an event with Oshkosh Truck, and then Rivian Motors, the new electric truck plant operating and just opened down in Bloomington. 2 things for tonight. Those that are looking for professional development hour credits, please send your request to our SAE mailbox here at the bottom, ms013@email.sae.org. And then I think that was what I had to cover.
Yeah, I'll just make a comment, Tim. So a lot of you requested PDH credit when you registered. I have a record of that, so thank you. So you don't need to send the email in if you did that. If you did not, check that box in registration, then and you still do want it, or you don't receive it, you can send a request to this email, and we'll get you the certificate.
Thank you, John. I forgot that was part of the invitation. So if there's questions throughout the evening, we'd request that you put those in the chat feature on Zoom so we can screen those and ask them as appropriate. And then if time allows, and depending on the questions, we can open it up to actually have them live to ask Rakesh about anything that you may have questions about. So with that, Rakesh Panda, he's a VP of Solutions and Services at Guardhat. Prior to joining Guardhat, he spent time at Ramp Digital, Cisco Systems, and a company some of you may be familiar with called Apple. So he holds a BS in Computer Science and Engineering from the National Institute of Technology, or CALA. So with that, I am going to stop sharing and turn it over to Rakesh.
Can you hear me okay, Tim?
I can, yes.
Okay, fantastic. All right, let me share. Thank you for that introduction, Tim, and really pleased to be here. Good evening, everyone. I think most of you are, actually you are all over the world. So good morning, good afternoon, good evening, wherever you are at. I will not take more time introducing myself, but I do want to introduce Guardhat. Guardhat is a connected worker company that is human-centric. And by that, I mean we have built a connected worker technology to improve safety and productivity, and that all is built keeping the worker, especially the frontline industrial worker, at the center of it. I looked up the history of SAE and I was just amazed, wowed by how long it has been around and the kinds of contributions it has brought to the automotive community. I'm really privileged to be here, and I hope that I'm going to tell you something that is going to be worthwhile and you're going to be deriving value out of this presentation. So connected worker technology, essentially we want to achieve two primary outcomes. We want to achieve safety, and in safety, we want to achieve productivity. Today, we are going to talk about two topics, two focus areas. One is I'm going to talk about how connected safety can move the needle in automotive manufacturing. The second topic I'm going to talk about is something very close to my heart, and I'm sure you guys are all very tuned into that as well, is how V2X or vehicle to everything technology can impact safety in the workplace, in the industrial workplace, as well as for smart cities where you have pedestrians constantly interacting with different types of vehicles. So my presentation, I would admit, is a little bit skewed towards automobile, but you can tell that similar kind of trends and similar kinds of conclusions can be drawn in the aerospace industry as well. So pardon me if it feels like I have not focused enough on the aerospace part of your society here. So I'm here to talk about digital transformation, connected worker, connected machines. These are essentially a key trend in digital transformation. But I want to say that the automotive industry has been actually a leader in digital transformation. You guys started way earlier than some of us, and we are actually following the lead in that sense. So what are some of the trends, the mega trends that I can look back and focus on from a digital transformation standpoint in automotive? First, more and more things are software defined. By that I mean how your hardware operates, how software actually drives the mechanical components of a vehicle. All of that has moved to software. Similar trends are seen in aerospace with fly-by-wire. That was introduced way back in 1968. The second trend is moving from physical to virtual. There have been an evolution of maps and in-car navigation, but what comes to mind is the introduction of satellite navigation in the Mazda in 1990. Before that, there were quite a few dead reckoning systems, but this really brought the car to a virtual map, which can be seen on the screen. The third trend is that everything is getting connected. Talk about all the components in the car, they're all controlled, centrally connected to the nervous system of the car, which is the onboard computer, as well as satellite radio. You have fleet management systems, and of course you have Uber, which is actually a big, large network of vehicles. This can also be extended to trucks and fleets. As you can see, every vehicle is getting connected. The fourth and the most recent trend is how more and more data is harnessed, not just from components within the car, but also the environment around the car to provide a much richer experience to the driver and keeping everyone around, including the driver, safe. The manifestation of that in an ultimate fashion is how self-driving cars are becoming mainstream. So talking about the similar kinds of transformation in talk about worker technology, we have office workers who have access to Zoom, which we are using right now, all the cool technologies to stay connected, Slack, virtual reality, all of that is in the hands of an office worker. But look at how the same transformation has panned out for the industrial worker. As you can see, not much has changed. We are still using radios. And this is where we felt Guardhat can make a difference in making a leap as far as how these four trends that I talked about can affect the industrial worker. To explain how these trends have affected the safety and productivity and how it has affected the life and the working of an industrial frontline worker, I'm going to use a framework called hierarchy of controls. So as I mentioned, I'm going to talk about manufacturing first and then talk about a little bit about V2X. So let's talk about the hierarchy of controls. This is the framework that I want to use to drive home how these four digital transformation pillars are actually making a significant impact onto how safety and safety technologies operate in the workplace. So many of you are familiar with this hierarchy of controls. These are the various types of controls that are exercised in an industrial setup to enhance safety. So starting from the top, if you can eliminate or substitute, that's the best way to keep your workforce safe. So think of eliminating a hazard altogether or substituting a hazard with something which is not hazardous. At the bottom, you see that if you cannot eliminate something, then obviously people have to wear hard hats. People have to wear gear which will protect them from high voltages or fire. Or administrative controls. You have these tape around hazardous areas. Or engineering controls. Figuring out how to keep guardrails or how to keep machines away from people. Those are some of the examples of engineering controls. Now, there are some characteristics of these hierarchy of controls. If you go from the bottom to the top, you see that the lower levels are involving a high cost to sustain. So, for example, think of all the consumables that are used for PPE, which have to be replaced, which have to be checked, which have to be managed, etc. Engineering controls, on the other hand, can have lengthy ROI. It takes a long time to realize the ROI. Whereas elimination and substitution, you have designed your shop floor in a certain way, it's very hard to change. So how can the four trends that I talked about affect and transform the way hierarchy of controls work today in the workplace? So let's talk about how data, which is gathered from smart PP, from sensors, from smart wearables, can actually move the hierarchy of controls from the bottom to top, where the cost is reduced because you are now able to apply virtual controls and you're able to apply software-defined workflows instead of defining actual areas with tape. You can now have a virtual geofence, or you can have controls where if you have the right kind of training, you are allowed to access a machine for maintenance. If you don't, you are stopped. Example of virtual controls. Similarly, all this sensor data, all the events, all the near misses are also gathering immense amount of data, which can be used for figuring out how to design a shop floor in the most optimal way that is safe for people. And that is where data-driven behavior analytics and artificial intelligence comes into the picture. So let me just pause and see if there are any questions before I move on. Hopefully this makes sense. And I also want to make sure that Sarah or Tim, if you're able to hear me okay.
Yep, chat's coming through good. Nothing in there yet, so you can keep on going.
Fantastic. All right. So moving on. Now that we want to exert control or affect a change in the hierarchy of controls, how do we do it? So here I want to introduce our flagship product, the smart hard hat that you see here on the picture. This is an example of a smart PP with multiple functions. It has a radio built in, it has an SOS button that you can see, it has the ability to make a video call, it has 3 different location technologies built in. You can use push to talk, you can take pictures, you can take videos. One smart PP that keeps you safe, as well as allows you to not have to deal with distractions, take out your phone, check what someone has messaged, or take a picture with your phone. All of that is managed through a single wearable, which is hands-free and which has all this technology that works seamlessly, that you don't have to think about it. It also detects when you are in a geofence. It tells you that, hey, this is a hazardous area, and it literally talks to you, telling you that, hey, you know what, you're not authorized or you're not qualified to go into this area. So this is one example here. Just taking it back to the hierarchy of controls. Think of how investing in smart PP is actually going to move the hierarchy of controls up, thereby reducing cost as well as improving the effectiveness. Because as you move up in the hierarchy of controls, it is the effectiveness is much higher than the levels at the bottom. We are not just talking about a wearable, we are talking about an entire system. Wearable is only the tip of the iceberg. So what are some of the impacts that you can see having this shift of hierarchy of controls? So this is an example of a wearable device which measures biometrics to be able to detect heat stress. So we used it in one of our customer sites where it's a steel plant where people are working in a coke oven. There are obviously high temperatures. Previously, there were controls in place to have periodic breaks. Everyone has to get off shift, get off their whatever they are doing, and take a break to cool down, have water, and make sure that it's safe to go back to work. But with using wearables, and this is a good example of an engineering of an administrative control, but using the wearables to measure biometric, the temperature, the heat stress, as well as the heart rate, what we were able to do is in real time detect if someone is experiencing heat stress, and not pull out everyone to go on a break, but depending on the person's biometrics, detect if someone is actually witnessing heat stress, take that person out, whereas everyone else can go about their work. as in the most efficient manner. Not only that, by looking at the trends in this data, we were also able to see that there are certain shifts which are prone to heat stress. There's just because of the weather patterns, we were able to detect that there are more people who are prone in this shift, and therefore we can plan the work so that the possibility of heat stress is minimized. Talking about how do we achieve this, and a good example is Internet of Things. As you've heard, machines are connected. We are gathering all this data from machines. We have outfitted machines with sensors, including in the automotive industry, in the manufacturing, as well as on the vehicles themselves. We have different sensors piping in data. We are gathering insights, and not only are we able to affect feedback loops in real time, but we are also gathering this data, doing historical analysis, drawing insights as to how we need to operate these machines when maintenance is due, and so on. If we take the same concept and apply it to people who are actually a pivotal part of the entire operation, if you don't have people working with their 100% effectiveness and in the safest possible way, it actually is going to impact the overall operation. And we can do the same kinds of things using smart PPE with people, and we call it the industrial internet of people. That is a concept, that is a term that we at Guardhat feel very passionate about, and we believe that the same kinds of efficiencies that you can achieve through industrial internet of things is what we are going to bring to bear using the industrial internet of people. Let's talk about the similarities and the differences between the two. You have connected things on one hand, you have connected workers on the other. There are certain care abouts when we talk about connected things: security, speed, efficiency, machine-to-machine communication, autonomous operation, multiple sensors, data is structured. On the other hand, you have connected workers. You have privacy and security, which never was a problem with connected things, but now we have to think about privacy and security. We have to think about human ease of work. We have to see how usable something is. It's not like you can have 20 different screens and expect the person to react to all of these stimuli. You have to make it easier. It has to be built for human communications. Humans are, as you know, quoting Elon Musk here, our interaction with machines, the input output is the slowest part. So you cannot expect us to be wired to the computer and the computer essentially understanding what we are trying to do. But the connected worker system has to understand human communication, human language. It has to be ergonomic and multifunction. So think about, having all these connected devices, wearables. At some point, we need to think about how do we make it easy, not light up a person like a Christmas tree with multiple wearables, but consolidate, like the example that I cited earlier of the hard hat, where multiple functions similar to what the iPhone did to multiple devices. We are trying to do the same with our hard hat, having a radio, having a camera, having a location device, having a mechanism to provide alerts, all of that built into a single device. Of course, human-machine interface, machines don't require an interface, but if a person is operating it, it has to have a human-machine interface. Talk about speech interface, a screen, making it super easy to understand. Human-machine interface is something that is very unique to the connected worker system. Not only we deal with structured data, but we also deal with a lot of unstructured data. Think pictures, think speech, audio, all of that has to be dealt by the connected worker system. And of course, there are some common elements of the two. Both are built for safety. Location awareness is huge. it has to be connected. That is one of the key factors. Of course, it is connected worker and connected things. So it needs a solid network. And not only does it need to connect to the IT systems, but it also needs to connect to the OT network as well. And not to mention the internet, if you want to draw insights from various data sources, which often are situated around the world, not inside the network of your company. And it's all data driven. Like I said, it's collecting data every second through various sensors and consolidating, putting together all of that data to generate insights. So essentially, connected worker is different from connected things, and here are certain things which make it more human compared to if you were just connecting machines. So this is a quick picture of the Coke oven that I was talking about. This is where we realized the impact with the biometric band that I was describing earlier. One of the things that I want to drive home is very critical to success. I think in the automotive industry, you guys do really well with change management. You have Lean Six Sigma, all of these, and you really understand deeply how change management can be make or break so far as these transformations go, especially digital transformation. We have a similar challenge. We have some tailwinds for us. Things like COVID-driven tech adoption has become easier somewhat, and we also have some headwinds like privacy. Workers are hesitant, but they have started to open up. Most of the times people are concerned about, are you going to be Big Brother? Are you going to be tracking me? Is that my personal data that is going to be used for not my own benefit, but for my employer's benefit, right? So those are some of the headwinds that we see that we often have to deal with in order to see this transformation through successfully. I do want to highlight, some of the breakthroughs that we have made as Guardhat from a privacy standpoint. This is obviously new technology. There are suspicions around how it's going to be used. There are features which we have very deliberately introduced to make sure that you are never tracked without your consent. For example, even though our devices, many of them have cameras, you can never turn on a camera without actually the person, the wearer, consenting to it or taking some kind of an action. Similarly, there are options for only tracking when there is a reason to be tracked. For example, if someone presses an SOS or someone is in danger, that or someone is on the site versus just driving home, we can have exercise fine-grained control over when someone is tracked and when someone is not tracked. We have the concept of blackout zones where you can fence out an area and define the rules to say that you are never going to be tracked in that area, and we can do those kind of things, taking this privacy into consideration so that we can affect change and deal with these change management challenges. Next, I want to talk about V2X and particularly V2P. I think that's the second intersectional area of our technology, connected worker, and the automotive industry. Many of you are probably aware of the latest and greatest, but I want to talk about four or five different things that we at Guardhat are focused at from a standpoint of vehicle to pedestrian connectivity. We have now purpose-built wearables that detect mobile hazards. I think there has been an inflection point in technology where ultra-wideband radio, which is very immune to all the kinds of interference in a typical industrial environment, has now become mainstream. That was driven by Apple coming out with their iPhone with an ultra-wideband chip, but we have been working on this technology for a while, only that Apple made it mainstream. right? So we are able to detect very accurately, how far a person wearing one of our smart devices is from a mobile hazard. Okay, and we are able to alert him or her on time, just in time to be able to get out of the way. We are able to alert the driver. We are able to take those actions in real time to be able to keep the pedestrian safe. I talked about geofencing. Controls, remember, are moving from physical to virtual. No more rails or tapes. We have a way to have virtual zones, and we can alert people as they're approaching a hazardous zone. We can tell people that you're not supposed to be here because you're in a zone. There are no markers, but still we are able to figure out the location based on various location technologies. Geofencing, another very important pillar, I would say, for our solution. One of the ways we are using it, for example, is we built a solution where there's a traffic cam looking at oncoming traffic and alerting the construction workers who are working in a zone which is geofenced, and alerting them when there's a vehicle that is actually over the speed limit, so that they are watching out, making sure that they get out of the way. We have ways to communicate peer-to-peer with systems, with humans and autonomous operated vehicles. One of our partners has a large fleet of autonomous vehicles. We're working on solutions to stop the autonomous vehicle or detect the autonomous vehicle, talk to the autonomous vehicle machine to machine, to be able to ensure that it stops or it doesn't go into a hazardous area. We are able to alert the person to also get out of the way if there's a vehicle, oncoming vehicle. I talked about the integration with traffic cams. Last but not least, I want to talk about near misses, the importance of near misses. There are these near miss events which are generally not recorded systematically, but because of these technologies, we are able to now record these so that we can analyze that, hey, what, in so and so location the near misses were more than in this other location, or being able to generate insights as to where these near misses are happening, which drivers, which vehicles, which pedestrians. Of course, we are able to get that data to generate insights to essentially plan and improve the safety posture in these kind of environments. So that's kind of the jumping off point for me to go into the demo. Before I go into that, I just want to give you a quick overview of the Guardhat platform. We see this as constituted of three different pieces. At the middle is the connected worker platform. This has the aspects of privacy and security, as well as some foundational components like comms. Think of audio-visual telephony, media servers, being able to connect various kinds of systems. All of that plumbing is what we call the connected worker platform. On the left, we have a growing ecosystem of wearables. There are different types of wearables for different functions. Some of them are multi-function, like the smart hard hat that I just showed you. Others are more specialized for certain types of work, like smart glasses, for example, or biometric tracking bands. You have different types of sensors, like gas detectors, for example, which measure the levels of various hazardous gases, being able to define thresholds on the fly, detect if there's a dangerous level of gas, being able to take some action, being able to alert. All of that is achieved through the ecosystem of devices. As Guardhat, we not only have our own wearables, but we are also committed to growing this choice of wearables for our customers, so that bring your wearable, but we have a single pane of glass where you're going to be giving you full situational awareness of how safe someone is in the workplace. On the right you have the single pane of glass, as we call it, the safety control center. That is a single screen that keeps track of all your sites, the entire workforce, their current location, whether they are safe or not, monitoring their condition 24/7, and last but not least, being able to communicate with them. But Safety Control Center is just our app. We also have our tools that we offer to partners who want to bring their own safety control center or their own analytics engine. The data is there for multiple apps, either mobile apps or web apps or analytical apps to either operate in real time or draw insight from the historical data that is captured. In many cases, every wearable sends messages every second talking about all the sensor readings, the events, all of that is available for analytics applications downstream. So let me pause here before I jump into the demo, see if there are any questions so far.
Yeah, we actually had a couple questions come through, so we could maybe go ahead and we'll give those to you. The first one, Rakesh, was how do you measure and report core body temperature? And if you're going to answer any of these in your demo, just let us know.
Sure. So we have a biometric band. I wish I had one that I could show you. We measure two things. We measure the core body temperature and the heart rate. And based on that, we have proprietary algorithms that take these two inputs and determine if someone is experiencing heat stress. But yeah, these are basically worn on the arm and they monitor the both of these components, the core body temperature and the heart rate.
Okay, and then we'll do maybe one more, then we'll go to the demo, and then I see more coming through. We'll get to the rest after that. You partially answered one of these after it was already put in, but do you need worker consent, and are there any concerns about HIPAA with regards to monitoring and storing a worker's vital signs like heart rate?
Yes, you do need HIPAA and you do need workers' consent. However, there are ways to minimize the storage of personally identifiable information or healthcare information in our system. The way we do that is let that personal information be with the individual, the employee. Whereas we track the heart rate and the core body temperature, but in most of the cases we anonymize that information. So, for example, you will see worker 1, worker 2 in our system, and we will notify the right person when someone is experiencing heat stress, but we don't have to store his or her personally identifiable information in the system. So it works on a system anonymity. We often rely on the HR system at our client to marry the information to a person, and most of the times we don't have to do that to take the right action.
Okay, so maybe now we'll go to the demo. We'll have more questions and we'll have plenty of time at the end, everybody, to get to these other questions.
Absolutely. All right, so let me start with one of our wearables first. Hopefully you can see this here. This is the smart hard hat. We call it the communicator hard hat. This was selected as one of the Time magazine's 100 best inventions of 2020. The real breakthrough is that we have everything and more that your mobile phone has, but in the form factor of a hard hat. So let's go over what you can do with this. So the first and foremost, we have an SOS button, which can be activated to. Actually, let me turn on the volume a little bit. So as you can see, the hat spoke to the wearer, and it also created an SOS alarm where I can click on the SOS alarm and I can see where someone is. So right now, this is the person here I'm indoors right now, so it's moving around a little bit. But you can see the history of events. You can see the sensor readings, the temperature, pressure, the noise levels as I'm speaking, and the humidity. So essentially the core sensor readings as well as the location when someone pressed an SOS. I can also cancel that in case I'm okay. What I can also do is there are inbuilt sensors in the hat which will detect a fall. So for example, so I see all the context information for the fall, where the fall happened, what are my ambient sensor readings, and if, let's say, I fell and I didn't move for a certain time, this fall will turn into what is called a man down.
Alert will be generated in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Man down alert.
So that's a man down alert that signified that someone fell and was not able to get up. So it's something more serious than just a slip or trip. So I'm going to resolve these. Go back to the hat here. I also have push to talk, which is the ability for people to communicate amongst each other. So I can press this button and it beeps. Yeah, and it changes. You can change the channel. You can go to the channel where you want to be at, and then you can use it like your push to talk radio, essentially all built into the hat. I can also make a video call or an audio call from the hat. So for example, I can so I'm going to mute myself so that I don't hear, you guys don't hear the echo. So essentially, think of a remote expert being able to help someone who needs assistance on the shop floor. I just make a video call and I can show the remote expert what I'm seeing anywhere in the world and be able to walk through, to either do an inspection or solve a problem. So that was a video call placed on the hat. Not to mention, you are seeing on the screen the location on a satellite map. I can send a message to either a single hat or all the devices or all the people through a very easy way. I can select, this is Mike's hat. I'm going to send him an audio message. I'm going to say, hey, Mike.
Hey, Mike, can you show up at the office?
So this just went as a simple message using ASCII onto either one device or multiple devices. You can also send messages to multiple people. You can send it to a single person. You can send it to everyone on a certain location, or you can send it to everyone. It's like a broadcast message. Next, let me show you an example of virtual controls. So we have invested a lot of time and energy in making this really slick in terms of the types of geofences you can define. So you can have a simple geofence where people are allowed or not allowed. You can have a blackout zone. You can define an evacuation zone where you have a hazard. You can create an evacuation zone. You can create a PP compliance zone, which means that someone who's entering this zone has to wear a hard hat or a harness or a gas detector, we will ensure that the person is alerted that, hey, you're entering a PPE compliance zone. These are the PPE required for this zone. So ensure that you're wearing it. And we take it a step further. Not only it's just a reminder, but we will require the PPE to be scanned onto the hat. The hat actually has a camera which can read QR codes. It also has an NFC reader, so you can scan a sticker to be able to say that this PPE is actually worn or available. So that's the PPE compliance zone. And of course, you have other types of zones that I will not go into in the interest of time. Not only do you have these standard types of zones, but you also can define new types of zones. There is no, these are not the zones that you're stuck with. You can define your own type of zone and you can create rules around that zone. So let's create a simple geofence. I'm going to use my location and I'm going to call it hazard zone. In this case, I'm not going to allow anyone to go here. Maybe there is some gas leak. Okay, so creating a geofence just takes a few minutes, actually less than a minute, few seconds. Just point and click on the area where you want to draw the zone. I can select people that I want to allow, who will be allowed to access, maybe because they're qualified or they are the ones who are authorized to get into this area. So I'm just going to select another tag so you can see this in action. I'm going to just say, Kaushik is allowed here, and I can just activate this zone.
Geofence violation.
So as you can see, Mike's hat was not authorized, and that's why Mike got a geofence violation alert. You can see that his hat is actually showing a red circle around it, and which means that there's a critical alert. As soon as I can, I remove this geofence, this will go.
You have exited a geofence area.
So it goes back to green, essentially. So that's a quick overview of geofences. As one is going about their workday, there are inspections to be carried out. There are various unsafe situations which one may run into, or just pieces of equipment or readings of a gauge that needs to be sent over to someone to look at. Right? So that's where the pictures and videos comes in very handy. And the shutter release button is right here on the top of the hat. You can actually either short press it for a picture or long press it for a video. And that's a picture, and I can also long press
Video
it to
recording starting.
just long press that to record a video.
Video recording ending.
So I took a picture and some videos, and I want to share it with my supervisor or my someone who can help me with something. So it automatically, as you saw, the videos refreshed and the picture came about. Of course, that's my setup here. That's my fancy web camera, and I can see what you guys are seeing on the screen. And there comes the video. I'm not going to play it, but the idea is that you have a secure vault where all your media is sent, so that it's not on people's phone where security or privacy is an issue. It's all managed within the enterprise, and it's available to the right person with the right level of access. Next, I want to go into the analytics section. So great, we have lots of smart devices, hard hats, tags. I didn't show you the tag. We have other types of devices as well, like this is a personal tag. It does lots of similar things as the hard hat. The main difference is it doesn't have ultra wideband, which is the precise location technology I was talking about. But other than that, if the hard hat is not the right form factor for some people, then you can just wear this tag on your shoulder or on the waist, or just keep it in your pocket, essentially with the same kinds of benefits. All right, so we collected all this data every second from these devices, we have a location, we have sensor readings, we have all the events, falls, man down, etc. So all of that is going into a single repository, where the idea is, again, going back to the concept of hierarchy of controls. We want to get this data, analyze it, apply algorithms, artificial intelligence, machine learning, to be able to design the workplace in a better way, to be able to affect process changes which are going to keep people safe, and in the process also make them more productive. All this data is available for downstream applications. We are showing you some examples here, but really the sky is the limit so far as what you can do with this data. You can apply your AI algorithms on it, or you can do simple reporting like the one I'm showing you. So in this case, first thing I'm going to do is I'm going to look at the overview report, which essentially shows me all the events in a certain site. Okay, it essentially reports who had how many events, where those events happened. You can see that these how many events happened in every location, and you can see the types of events essentially. Okay. The KPI report is a report that really talks about how long it took to resolve events, critical events or non-critical events, and it gives you a trend by time. So I just selected days, and it shows you, how many events took place on each of the days, how many critical versus non-critical events. These are simple examples, but essentially this is more illustrative than what many customers will like to do with it. They probably want something more sophisticated, but you have the data to get that something more sophisticated. These are all the zones. Essentially, you can see all the zone violations by again clicking on the event will show you where it happened, and whether any nearby workers, the history of events, and everything about that in the context of that event. Location report is something that is very popular amongst our customers. Think of being able to tell where someone was on the site. Of course, assuming that there was consent granted. So I can pick a person, and we pick Mike's hat and figure out where Mike was in this time. Okay. While that comes up, any questions we can, I'm almost near the end of my demo. We will open it up for Q&A for the next 15-20 minutes or so. So there's a lot of wiggly lines, but probably something like this is more useful, where I'm looking at where Mike spent his time on the site. As you can tell, we are doing a lot of demos from our home, and that's where all these the heat map seems to be concentrated on just my home here. Next, we can also look at all the sensor readings, get a report of, okay, so let's look at, well, so I can see the sensor readings historically for the hat that I was just showing you. There are 4 types of sensors: temperature, pressure, humidity, and noise. You can see the trending in a time series of those sensors. So while this comes up, all right, looks like I'm operating too many devices here. So while that comes up, let's see if there are any questions.
Sure. We actually have several questions. I am going to invite Aaron Perry to go ahead and ask a question live. So Aaron, I'm going to unmute you. And if Aaron's having trouble getting off mute, I'll go ahead and ask it. I'll go ahead and ask it. Oh, go ahead. Sorry.
I'm joining Rakesh here as well. I'm Sarah Calhorn. I'm with Guardhat. I'm just going to help him in the Q&A section since we made him talk for a full hour.
Yeah, so I'll go ahead and ask Aaron's question. So are all alerts audible? or is there a vibration notification to mitigate PD strike? Pedestrian
Great
strike.
question. So it really depends on the device. The hard hat itself, we believe that the audio alerts are the best way to alert. We don't want haptic alerts going on in your head, but the tag, absolutely, it has 3 kinds of alerts. It has audio, haptic, and it also has screen alerts.
Great. And then to piggyback off of that, with on the last thing that you showed, you had worker, but then you also had the forklift tag. Is that for moving or is that just for asset tracking?
That's actually for the worker collision avoidance solution.
Okay, that's what I figured. Thank you so much.
Yep.
Okay, great. Mike, it looks like you have some questions. Go ahead.
Sure. I was asking, based on like the customers that you've been working with, have they surprised you with anything afterwards? Because like we have some kind of on-command connections in the Navistar trucking industry, and they always come up with new stuff that, you know, was unique that we didn't think about when we were rolling out kind of this GPS tracking, similar to what you guys have for people. Has there been anything fun that you guys, you know, didn't expect when you guys were rolling out this product? It's always fun to hear what, you know, some of your customers come up with.
Yeah, we have, you know, we definitely customers, you know, come up with a lot of innovative ideas. I'm trying to think of my favorite one. It'll come to me. But yeah, we keep hearing all these kind of interesting ideas all the time. Like, being able to stream video from an offshore rig over a 200 kilobits per second connection, which is almost next to impossible, or getting really close. Well, here's a good one. One of our railroad customers wanted to use GPS to detect if someone is on the on one side of the track or the other. It's actually extremely difficult to do with GPS, given, like, you know, you have 2 to 5 meter accuracy, but they really wanted to keep people away from the track, you know, at a safe distance, and they wanted to use our devices. There are ways to handle that, but yeah, there's a lot of expectation that you can often get like pinpoint accuracy with the existing GPS technology. That is changing, of course, but yeah, we keep getting, you know, these kind of ideas all the time. Sarah, anything you can think of?
Yeah, I think some of the interesting ones is one of the groups, a construction company that saw our collision avoidance solution, said they wanted to put those actually on their cranes just to alert people when they're overhead, because workers get freaked out when they look up and they see a crane. They're like, oh God. So just for the stress relief alone, they wanted to alert workers if they're going into a zone where there are cranes overhead. And that same group actually talked to us about the video capability for recording incidences on site that we hadn't initially considered in our initial platform, like sexual harassment, violence from outside or third parties, that just having each worker enabled with immediate communications and SOS and even video capture capability would help support some of those issues that they'd seen on site.
That's great. Tim, looks like you had some questions as well. We'll go ahead and open it up to you.
I did. First one's pretty easy. Can the SOS feature be connected directly to 911? Or is it strictly to whoever is doing the controlling or monitoring of these?
Yes, it can be connected to 911. Yeah, it
Okay.
can be connected to a dispatch emergency response, or it can be your own emergency response. It can be a supervisor. It's pretty viable that way.
Okay. The other one I had, can you discuss the sales of the Guardhat technology at all, or maybe some of the typical customers that are using this?
Yeah.
Sarah, you want to take
I'm
that?
happy to take that one. So I'd say the areas where we have moved fastest and are, seeing the quickest ROI and the quickest pickup are areas where there's the most danger to workers. So metals and mining, construction, oil and gas and chemical. But as Rakesh was speaking to, we have customers in general manufacturing, in lumber mills, in rail yard operations. We also have our tags being used at corporate events for COVID track and trace solutions. So there's a wide group of folks that are using it, but I would definitely say those sort of top 3 hazard industries are where we're seeing the most immediate traction.
That's good. Then how long has this been available to the market?
So we started developing, the company was founded in 2014, and then the hat took about 4 years just to develop the hat. And then the effort transitioned to developing the Guardhat platform, which is that IIoT system for people, that IIoP system. So the hat officially launched last year, 2020. And then we developed the other devices and shifted to COVID track and trace. So we've been fully in the market since 2020, and I would say have recently shifted to see a lot more of the software sales, especially as our integrations have expanded. So now we can connect into gas detectors that are already fielded. A lot of the smart Vuzix or RealWear smart glasses that people have deployed. So some folks are jumping in on our software without even using our devices, or just using our devices as data ports for other information.
Very good. Thank you.
Great. So next we have Mithun Shetty. Mr. Shetty.
Yeah, thank you. Yeah, nice presentation. So I have a question, what is your alert zone radius? Is it 100 meter or is it adjustable? And if it's a forklift, do you consider variable travel speed and the reaction time has been accounted for? And is that are you using some standard or is it a proprietary protocol?
Yeah, all great questions. Please remind me if I miss answering any of your questions.
Sure.
So first, the alert distance itself is completely customizable. We have two types of alerts: the alert to the person, as well as the alert to nearby workers. Let's say if you press SOS, we want to tell the nearby workers that someone is in peril, right? So we can control what is the radius of nearby workers who get alerted. We can also control how much distance before the geofence, before you're entering a hazardous zone, you will be alerted. We can also control the distance. If it is a human to machine type interaction, we can control what is the distance. And there are two types of collision avoidance technologies that we are currently experimenting and solving for. One is where the vehicles are controlled. Let's say if you're in a warehouse environment, there are 10 forklifts. So those forklifts also have transponders attached so that we can tell how fast they're moving and where they are on the warehouse floor, in relation to the person. We can, see through blind corners. We can tell how far the person is. We also, by virtue of these technologies, we are able to say how, what should be the reaction time and how far, how quickly the vehicle is going to be at an unsafe distance from the pedestrian.
Okay.
I think the last question you had was again.
Yeah, are you using proprietary or using a standard?
No, so some of it is proprietary, some of it is standard. I think there are V2X is still a new area. There are new standards coming up. We use ultra wideband as our kind of location technology of choice, but we are being a software platform vendor. We are constantly working with ecosystem partners who bring their own technology, like magnetic waves to detect proximity and so on. The other type of collision avoidance we deal with is uncontrolled vehicles. So maybe a rail yard worker who is in proximity with rail cars, right? These rail cars don't have transponders, right? But we still can detect like some types of we use the standard radar technology to be able to detect if there is a moving obstacle or kind of a mobile hazard which is coming your way. So that's another type of collision avoidance that we are also working on.
Thank you.
Mix of proprietary and open standards, I would say.
Sure. Yeah. Thank you. Thank you for answering. I have a couple of more questions, if it's okay. So, like right now, the 4G connectivity for hard hat, is it like has an inbuilt cellular modem, or are you using the Bluetooth on your phone for connectivity?
Yeah, glad you asked that, Mithun. Actually, this gives me a chance to talk about all the connectivity options that that our devices, including our hard hat, has. So there are essentially two different, mainstream communication technologies, Wi-Fi and LTE, with the ability to switch back and forth. but we also have Bluetooth in our hard hat, so that, you know, but it doesn't require tethering through a phone. That is not suitable for industrial, because many times industrial workforces don't carry your standard cell phones, or they're out of reach for most people. So we don't rely on any phones. Rather, we either, if we go down the route of Bluetooth, then we often use gateways, long range gateways, which can detect multiple devices in an area.
Okay, so do you support multiple band in LTE then?
Yes, we have deployments all across the world, and as you know, LTE bands vary across countries. So
Okay.
we do support multiple LTE bands.
And one more question is that push to talk, is it cellular based?
No, it is not cellular based. Currently, it is VoIP based, and we believe that these industrial workplaces are getting more and more connected. So really, VoIP technology is the way to go. That is where we see the developments leading to. Not to mention 5G, which is going to even make it better, or satellite connectivity, which is becoming more and more mainstream.
Thank you very much.
Sure. I do want to, taking off your question, I do want to highlight that our devices also work in offline mode. So for example, the devices have the ability to download geofences, and even if there is no connectivity, we can still detect if you're in a geofence or not. So store and forward, as we call it, is kind of mainstream for all our device ecosystem.
Great. All right, so next we have two more questions. We'll go to Ken Cinco. Ken?
Yeah, I had a question concerning sort of maybe the intrusive nature of some of the technology you have. For example, you mentioned my core body temperature could be reported to my employer, or perhaps maybe my near miss activity with collisions could be reported to my employer. And I would imagine that some work environments, particularly maybe those that are unionized, would have resistance to adoption of this technology. Can you talk about how your technology mates up with a workforce that on one hand might tend to embrace it, or another one which might tend to regard it with suspicion and reject it?
Yes, great question, Ken. Glad you asked it. So two-part answer. I'm going to ask Sarah to answer the union part of it, but just talking about the biometric data, there is no rule that we are going to report this data to the employers. It may be an alert to yourself, for example. Okay, so it's not shared with the employers without your permission. There is always consent, and there is always control that the employee can exercise. Although there is a dichotomy that employers want to track everything and employees don't want to be tracked at all. So there is probably a middle ground that we are always trying to find, and every workplace has a different middle ground. So we try to figure out what is that. But we offer enough choices so that that middle ground can be found easily. So far as unionized workforces, yeah, absolutely right. Sarah, do you want to throw some light on some of the things we have done from a union standpoint?
Yeah, I'll start by saying, being founded in Detroit, we had great relationships with the UAW. And so we actually started with the team there and talked through at the very beginning, this is our framework for privacy at both the device, process, and system level. So we were getting union input from the day one, because we recognized how important that would be. We're actually currently working with some German unions, the two big German unions, hoping that if we get it right there, we can get it right anywhere. So we will see how that goes. I'll speak to one specific deployment we had in a company this summer, where there was one union shop and one non-union shop, and we assumed the non-union shop would be a breeze. And I'll tell you that actually the group that we had union involvement, we presented to them, we showed them the ins and outs of how the platform works, where the data goes. And the union supported it, and therefore helped us with the communications to the workers, and the workers, we saw hardly any issues there. Oftentimes some of the issues we see would be the workers taking the devices off, leaving them. There's been a few cases where they, damage the camera, things like that. So those are this is an issue we need to address at every site for sure. organizations where there's good trust, where the COO or the union steps in and supports us, someone with operations expertise and history and legacy and trust. If they show them and talk about how this is for safety and this is what our plans are, we see a lot more success. But it's definitely something we address in every rollout because it is an issue that needs to be addressed. And I liken it a bit to how horribly freaked out I was when Amazon started telling me what to buy. And within a few years, I was like, what am I supposed to buy next? And so I think this stuff will start to happen in industrial spaces. And we want to be people that bring the workers and the unions along in the front row seat for sure.
Great. So we have one last question from Dan Carlack. Dan?
Hey, everybody. I'm assuming that there's just one person who sits at a screen all day and kind of monitors all of these hats. Is that true?
That is certainly possible, but that is not how most of our customers use it. So many of the larger industrial operations have a control room where someone is monitoring 24/7, but we have the ability to notify the right people through either text or email, so that you never have to look at safety control center as such. But there are some customers who have those kind of control room operations where the entire site with all the workforce is monitored 24/7, especially in hazardous environments.
Okay, very good. Thank you. One quick follow-up one, if I may. I'm wondering how long does it take a guy or a person to get used to learning which button to push? Because it seems like you're wearing this on your head and you can't really see the buttons. Is there a big learning curve to know which button to push, or do the buttons themselves have like a different texture or feel to it, so you know which button to push? How does that work?
It has a certain texture, and you can see the shapes are also different of the various buttons. One of my colleagues uses the analogy of the windshield wipers. Different cars have different windshield wiper mechanisms on different sides. So it takes like just the first couple of times to get used to it. What we have seen is within a day, a day of use, people get completely familiar with the various buttons and how to use them. Typically a training, yeah, go ahead.
They're really large buttons, and there's one on top of the brim for video and picture capture, and then the ones under the brim, there's 3 or 4 that they're using regularly. So I myself had to get accustomed to it when I joined the company, and it was the 3rd time I'm using it, I'm not looking or thinking about it.
Okay, very good. Thank you very much.
Real quick with I think I mentioned at the beginning that we have a large contingent of students at IIT listening in tonight. And Mo, does anybody have any questions there? Or are you guys still working on the leftover pizza?
Thank you so much. So one of the questions that we had over here is what are the opportunities for an industrial collaboration between the IIT Motorsport, the Formula Student team here, and Guardhat Technologies, if that's possible in some sense?
Yes, absolutely. So we would love to get in touch with you and figure out ways to collaborate. So Sarah, help me. What's the best way to get us connected?
Absolutely. So the team here that set this up, Michael and Tim and John, have my email address, and we've got a big team in Chicago. So we can, meet at our offices and show you guys how it works in real life, or come down and do a demo there for you guys on site as well. And we can sort of start talking from there, but we'd love to do that. We're hiring. A lot of our jobs are a little bit more senior right now, but we definitely want to stay in touch, because Chicago's our fastest growing office, and we want to keep building there for sure.
I'll make sure to get you guys in touch.
Yeah.
One other fun one that came in, I guess, is how do you charge this? I'm guessing you have to plug it in or wireless, and making sure we're lasting 8, 10, 12-hour shifts.
Yeah, great question. So as you can see, I'm showing you the back of the hat. There is a battery which is actually detachable. It just screws on and screws off. And there is a 4-unit charger where you can charge it. It takes about a couple of hours to charge and gives you a full shift, about 8 hours, 8 to 12 hours, depending on usage. You can also carry a spare battery to, if you are going to record a lot of videos, etc., you can swap the battery and continue to operate it.
I think you just covered Emma's question that was talking about battery life and how do you charge. So thank you for doing that.
That's where it came from. Yeah.
I also saw a question about intrinsically safe versions, and we do offer intrinsically safe versions of almost all our devices. Some of the third-party devices we use don't have those yet. A lot of them are at least roadmapped. Our hat received intrinsically safe certification in Europe earlier this year and is expecting C1, D1 any day.
For us not in the industry, what does that actually mean? I was confused by the wording.
Intrinsically safe?
Yeah.
That you can use it in potentially explosive environments. So where there's chemicals or dust and things like that. So it's fully sealed. And I think it was the largest device that had a cellular modem inside of its size, surface area wise, to ever receive that designation. It was hard. It took a long time.
So that could also apply then to mining, underground mining operations.
Correct. There are additional certifications from MIOSH, I think, as well, that we have not yet obtained. But yes, that is part of the process there too.
Okay, very good. All right, I think that was a very, very good presentation. Appreciate your time, Rakesh and Sarah, and sharing all this with our team. So if there's no other questions, you can just wrap up here quick. I think we went a little bit over our hour target, but I think there were a lot of very good questions and good discussion going on. There will be a recording posted on our YouTube channel. I didn't show that in the social media section when I was talking about that for our SAE section, but that will be posted here in a few days. So if you wanted to share that with your colleagues, please do so. If you need more information on SAE, feel free to reach out to any of the officers that were listed or through the invitation that was sent to join SAE, follow us, and hopefully participate in future events. So with that, thank you for attending, and we'll talk to you all soon.
Thanks so much.
Thanks.
Thank you so much, everyone.
Thank you, Guardhat.
Take care.
Good night.
Good night.